Hi, welcome to Data Structures and Algorithms series by Coding Ally. Coding Ally is a non-profit organization where we believe women and gender minorities should have a safe space and support system where they can foster their skills and careers in tech. I'm your host Sue. Today, we are solving this legal problem 121, best time to buy and sell stock. This is the agenda. First, I'll go through the problem statement, and then out of the 3 projects that I have listed here, I'm going to go through greedy approach. So this is the problem. You are given an array of prices where prices I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choose a different day in the future to sell the stock. So this is the constraint. Return the maximum profit you can achieve from this transaction. If you can't achieve any profit, return 0. Let's have a look at example 1. This is the price array 715364. From here, we can see that if we buy on day 2, the price is 1. We sell it on day 5, price is 6. The profit will be maximum. We can't buy and sell on the same day because of this restriction. So I've drawn that diagram just to illustrate that. So from here we can see that from this graph we can see that we can buy on this day, which is 1, sell on this day 5 minus 1 4, we make profit as 4. And again in here in this green color highlighted, you can see here 6 minus 3 is 3, so 4 3, but 6 minus 1 it is 5. So from here we can see that we have to choose the lowest price, we have to choose the highest price. Let's have a look at example 2. In this example, you can see here that the prices, they are decreasing, and so regardless of what day we buy, we are not going to make any profit, and it will be, let's say we buy on day 7, we sell on day 6, the profit is going to be at least minus 1, which is less than 0, so the maximum profit is 0. The constraint here, the price length is between 1 and 10 to the power 5, and the price value itself is between 0 and 10 to the power 4. So let's have a look. So in this video, I want to solve this problem using the greedy technique. So before I go into greedy technique, thought process behind, I first want to go through this. What is the greedy algorithm technique and what are the limitations it has? So greedy algorithm is an algorithmic strategy that makes the best possible choice, best optimal choice at each small stage. This means the best locally optimal choice will lead to a globally optimal solution. So that means that the algorithm picks the best solution at the moment without regards for the consequences. Whatever happen in the future, we don't care. We will choose the best. We will choose the one that is best for us right now. That is the greedy approach. So greedy technique is used in optimizing the problem. So you might think, oh, that's really good, but there would be a limitation. Yes, there is. The limitation is sometimes greedy algorithm fails to find the globally optimal solution because they do not consider all the data. So you can't solve all the problems with the greedy technique, but in this particular problem, we can use the greedy technique. So first, I will go through the steps process, and then I will go through the example step by step. So first, we have to initialize these 3 items. First is the buy cheapest, which is the lowest price. Instead of calling by lowest price, I want to use because the problem name is buy and sell, so I want to be very descriptive. So I want to so then variable name is buy cheapest. Next is sell today profit. So this is to check the current profit. How much profit are we making right now on this day, on today? Next is sell max profit. It's to keep track of the maximum profit. Step 2, we will iterate through the price array and we check. If today price is less than the buy cheapest, that means that we will we won't be, we buy cheapest is not the lowest price, so we will update that. Step 3, we are going to calculate what is our current profit. So for that, we will subtract prices at that today value and with from by so we will subtract from prices at today value and then buy cheapest. From this we will get the today profit, and then we are going to compare. If today profit is higher than the current max profit, then we are going to update it. So this is the process that we are going to follow. So let's have a look at the example. This is just to remind you, with the brute force approach, with that the time complexity of O and square, we can't solve this problem using the brute force. Therefore, we are using this greedy approach. So in here, the arrow should be pointing to here. Sorry about that. So we are initializing these 3 variables. Sell max profit initialized to 0, buy cheapest, and number.max value. If you come from Java or other programming background, other programming languages, that could be, let's say, integer.max value. So this is in Java. This syntax is JavaScript. So first we will check. Well, so we check. No, I think the arrow, yeah, it can be here. So current price is currently here. So we check. Current price is here, and then buy cheapest. Previously, we will say that, okay, on this first day we are going to buy it, because we don't know, it could be the higher, lower or higher, we don't know. So we set this as buy cheapest, and then we are going to compare these 2 values. So 1 and 7, of course, the minimum value is 1, so buy cheapest will be 1, and then we will calculate the profit. And when we calculate the profit, 1 minus 7, and we will have a negative value. And because of the negative value, when we update it, it will be just 0. So next, so far our sell max profit is 0, buy cheapest is currently 1, and then now we are here. So buy cheapest, we are going to compare. We are comparing these 2 values. Currently is 5, buy cheapest currently is 1, of course minimum is 1, and then we are going to calculate today profit. 5 minus 1, it's going to be 4, and then we are going to calculate the max profit. We compare currently 0 and 4. When we compare, of course 4 is higher, so we are going to select 4. 3 again, so we are going to compare the value, the current price, with the buy cheapest, which 3 and 1, of course 1 is lower. Sell today profit, so we are going to subtract 3 minus 1, the profit will be 2. We compare these 2, we compare the profit, current profit, and the max profit. So 2 and 4, of course 4 is higher. Next, we are now day 5. So day 5, from here we can see that the value is 6 and 1. Of course we will still keep that this is the buy day, we will buy on this day, and we will calculate the profit. So in here we can see that 6 minus 1, which is 5. So now we are going to update it, 5 and 4, because currently is 4, and then after we calculate the today profit, we can see that, oh, it's higher. So this is the locally optimal solution, so we are going to update it. So update to 5. So after updating to 5, so in here current profit is 5, the cheapest is 1, and we are going to, the today price is 4, so we still buy on this day, and we are going to, the next step, we will sell 4 minus 1, which is 3 and 5, of course 5 is higher. So by the end of this iteration, then we can see that the maximum profit is 5. So how is it? It's a greedy approach. So in this approach, you can see that best locally optimal choice in step 3 that we are doing, and then globally optimal choice we are doing that in step 4. So greedy approach make you rich. So let's have a look at the code. So these are the 3 variables. Buy cheapest, we first initialize the to num.max value, and today profit to 0, sell max profit to 0. Step 2, we are going to iterate through the array and we check at every single ith value. We are going to compare with the buy cheapest. If the today value is less than buy cheapest, then we will update it. Step 3, calculate today's profit. That's what we are doing. Prices I minus buy cheapest, and then from here we are going to get the today profit. Last, we are going to update the global profit. So that's what we are doing in here. Sell max profit is equal to max, and we are going to select the max higher value out of these two, and then by the end of the array we can return it. We can return the sell max profit. So in terms of time and space, time complexity is O of n. We are going through only one. We are iterating the prices array only one time. Space is constant O of 1. So we can optimize this a little bit further. Just not optimization, just the cleaning up this part. So with that, in here we are using the min, and this is the only this part is a little bit clearing up the code. So this code is slightly shorter, but the logic is exactly the same. So this is the comparison between brute force and greedy. Brute force, as you can see, O of n squared. In greedy, we have gone through the array once, we achieve this, and then O of n. With that, we come to the summary conclusion. In this video, we have learned what the greedy technique is, what are the uses and its limitation, and how we use the greedy algorithm, how we use the best locally optimal choice, and how we use the globally optimal choice in the step-by-step approach. And with that, we optimize the brute force approach, which was O of n squared, which is the time limit exceeded, and we bring it down from O of n squared to O of n. So thanks for watching. Please make sure to subscribe and press the like button if you find this video helpful. Join our weekly Wednesday data structure and algorithm night, where we organize peer-to-peer coding interview. You can find event details on our Facebook page. Thank you.